Example number 5. We're given the function f of x is equal to 3x cubed plus 4x squared minus 5x minus 2. Now, because the leading coefficient is 3, and the constant coefficient is negative 2, the first and the last term, the rational zeros are going to be the factors of 3 and 2. Okay? So it's the factors of negative 2 over the factors of positive 3. And so luckily for you guys, these are prime numbers. So some combinations of those right there are going to be factors. And so what we do is we use synthetic division to try to pull out the polynomials, and then maybe we could use a quadratic. So this will look like x plus or minus one of these numbers times a quadratic. And maybe we could factor the quadratic, who knows. So I'm just going to start with the first one, which is 1. So I'm going to say 1, and remember we've got x cubed, x squared, x, and then x to the 0. So I'm going to say 3, 4, negative 5, and negative 2. We have to be careful. Oh, I know what happened to example number 4. We have to be careful here because we want to make sure that every value of x is represented. Or every power of x, I'm sorry, is what I should have said. So now to do synthetic division, drop down the 3. 1 times 3 is 3. Add those up. 7. 1 times 7 is 7. Add these up, negative 2. Add these up, negative 4. Wait a minute. Somewhere I made a mistake. Oh, this is positive 2. All right. So that's a remainder of 0. Okay? So that means this is x squared, 7x. Now remember, this is saying x equals 1. So what I really did is I divided by, if I set that equal to 0, I divided by x minus 1. Does that make sense? So what I just did is I figured out that this f of x is equal to x minus 1 times 3x squared plus 7x plus 2, because this is a positive 7x. So now if I want to factor this any further, I might be able to factor these two numbers. Or I mean factor the quadratic. Now the way that I would factor the quadratic is I could do a guess and check. This is 3x squared, this is positive 2, I don't know, 3x times x, right, is how I get the first term. Now I need to multiply, I need two numbers that I multiply that give me 2, but when I add them up, these terms here, they have to add up to 7, right? So these two terms always add up to equal this middle term. Now if I put 2 and 1 here, what's 3x times 2? What's 1 times x? Does that add up? Yeah. So what I've done is I figured out that x minus 1 times 3x plus 1 times x plus 2 are the factors of this cubic. So to find the zeros, that I set it equal to 0. Now, only one way to guarantee that that's 0, think in terms of this. It has to be 0 times 0 times 0, right? which means that x minus 1 has to equal 0, that 3x plus 1 has to equal 0, and x plus 2 has to equal 0. So I get x equals 1, I get x equals negative 1 over 3, and I get x equals negative 2. How do I verify that? Anybody have a suggestion? Graph it. Now, where are the zeros going to show up on my calculator if I graph this? Those are the x-intercepts, aren't they? It's when y equals 0, so these x-intercepts should show up. So if I hit 3x cubed plus 4x squared, oops, gotta square it though, minus 5x minus 2. Nope, want minus 2. Okay. And I'm going to zoom this in at the standard. Oh, I got to turn my plot off here. Now, if I hit trace and I say 1, right, because over here I have x equals 1, and hit enter, notice what the y value is. If I hit negative 1 divided by 3, notice what the y value is. If I hit negative 2, notice what the y value is. Okay? Now, another way I could look at this, go into the table of values. I have a 0 at 1, I have a 0 at negative 2, and I'd have to go in and change the increment to look at negative 1 over 3. But I would have a 0 there as well. Does that make sense to you guys? Okay.